Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. And a very good day I bid to the viewers and my fellow friends. I, Muhammad Najmi bin Matwa, with my fellow friends from Group 4, will be covering this subtopic of system of linear equation for this entire video. So stay tuned. So in today's video, I will introduce for the viewers about what will be learned in this chapter. So the viewers will be learn about a system of linear equations with m linear equations and number of variables can be written as below. A solution to a linear system are real values of x1, x2, x3, and xn which satisfy every equations in the linear systems. If the solution does not exist, then the system is inconsistent. So in this chapter, the viewers will be learn about 4 methods that can resolve the question for this chapter. First of all, the viewers will be learn about Gauss elimination method. Second of all, you all will be learn about Gauss-Jordan elimination method. Thirdly, inverse matrix method. And lastly, about Cramer's rules.
So this is the example of the Gauss elimination method. For this question, the first one is x plus y minus z is equal to negative 2. 2x minus y plus z is equal to 5. Negative x minus 2y plus 2z is equal to 1. For the next step is we need to construct the augmented matrix, which has been shown here. Firstly, we need to use elementary row operation to transform this matrix into echelon matrix. In order to get that, we need to make sure this circle number in value 1 and also this circle number in 0. Now I'm gonna add row 1 and row 3. Then we will get negative 1 plus 1 is equal to 0. 2 plus 1 is equal to 3, 2 plus negative 1 is equal to 1, and 1 plus negative 2 is equal to 1. I'm sorry, negative 1. So next, I'm going to apply changes to row 2. So I'm gonna multiply row 1 with negative 2 and add that with row 2. Then we will get on row 2 is negative 2 times 1 plus 2 is equal to 0. Negative 2 times 1 plus negative 1 is equal to negative 3. Negative 2 times negative 1 plus 1 is equal to 3. Negative 2 times negative 2 plus 5 is equal to 9. So we're going to put that on row 2 and everything else will remain constant. Next, we will change row 3. So we're going to add row 2 and row 3, and row 1 and row 2 will remain the same. So for row 3, the first one is 0 plus 0 is equal to 0. Negative 3 plus 3 is equal to 0. 3 plus 1 is equal to 4. 9 plus negative 1 is equal to 8. Next is we're going to change this matrix into echelon form. So I'm going to convert negative 3 and 4 into value 1. Therefore, simultaneously, I'm going to multiply row 2 with negative 1 over 3, while row 3 will be multiplied with 1 over 4. After we get the echelon form, I'm going to label the first column as x, the second one is y, and the last one is z. Lastly, by using back substitution, we are going to get x plus y minus z is equal to negative 2, y minus z is equal to negative 3, and z we will get value 2. To get value y, we're going to substitute value 2 into z. So we're going to get y minus 2 is equal to negative 3, so y is equal to negative 1. To get value x, we're going to substitute value y and value z into the equation. So x plus negative 1 minus 2 is equal to negative 2. So x is equal to 1. So the final answer is we're going to get x is equal to 1, y is equal to -1, and z we will get 2.
Hi, my name is Danish. Today I will be explaining the Gauss-Jordan elimination method. So this will be our question to be solved using this Gauss-Jordan elimination method. The first thing we need to do is we need to construct the augmented matrix. Then we will get this form. So what's the difference between the Gauss elimination and this Gauss-Jordan elimination method? The Gauss method will only change the values to 0 at the bottom left corner and using substitution afterwards, while Gauss-Jordan method will proceed to change values to 0 at the top right corner. Alright, moving on. First, we need to change this number 1 to 0 by subtracting R1 with R2. Then we will get this matrix. After that, we change the value 2 to 0 by using the equation -2R1 plus R3. Then we will get this matrix. Then we will need to change the value -1 to 0 by adding R2 with 2R3. And then you will get this matrix. Moving on to the top right corner, we will need to change the -1 value to 0 by subtracting 3R1 with R2. After that, the value of -3 here will be changed to 0 by adding R2 and R3. Then, after getting this form, we will also need to change the value 1 to 0 by subtracting 2R1 with R2. Alright, we are done with converting the values to 0. After that, to put it in reduced row echelon form, we will need to make these three numbers to 1. So I will multiply the first row with 1/6, the second row with 1/2, and the third row with 1/3. So as the result, we will get this matrix form. Keep in mind that from the left column, that's the value of x, y, and z. So that x1 is equal to 6, y1 is equal to -1, and z1 is equal to -2. So the answer of this question will be x equals to 6, y equals to -1, and z equals to -2.
Assalamualaikum and hello to everybody. I am Yusuf Hamdani and I will explain how to do the inverse matrix method. Okay, first of all, from the number 1 we can get the questions, and then at the number 2, step 1, we need to check whether the determinant is equal to 0 or not. And then at the step 2, at the number 3, we need to find the inverse A by using adjoint method or arrow. And then at the number 4, to find the inverse of A, we need to put the formula that is 1 divided by determinant and multiply by the adjoint A. And then at the number 5, step 3, solutions for x is given by inverse A multiplied by matrix B. And then we will get the value for the x, y, and z. Okay, that's all from me. Thank you.
Next, we go to the Cramer rules method. Cramer rules is a specific formula used for solving a system of linear equation containing as many equations as unknown, efficient whenever the system of equation has a unique solution. Let's look at this example. Use Cramer rules to determine the solution to the following system of linear equation. X plus 2x equals to 9, 2x plus 4x minus 3x equals to 1, 3x plus 6x minus 5x equals to 0. The first step is write your linear equation to 3 times 3 metric equation. Next step is write down the main metric and find its determinant. So the determinant of for the linear equation is -1. Step 3, replace the first column of the main matrix with the solution vector and find its determinant. So the determinant 1 is -1. Step 4, replace the second column of the main matrix with the solution vector and find its determinant. So the second determinant is -2. The next steps is replace the third column of the main matrix with the solution vector and find its determinant. The last step is to find x1, x2, and x3. To find x1, x2, and x3, we use all the determinant divided by the main matrix determinant. So x1 equals to -1 divided by -1, so we got 1. x2 -2 divided by -1, we got 2. And the third determinant is -3 divided by -1, we got 3. So the answer is 1, 2, and 3.
Okay, in conclusion, all of this method will get you the same value of x, y, and z. If you guys try one question by using all of these 4 methods, you will surely get the same answer. So I hope you guys can understand all the method by the example given. Thank you for lending your ears and thank you for your attention. Terima kasih.